Okay, let's dive right into this explainer. I want you to treat your Cambridge computer science exam exactly like a paleontological dig. Think about it. We are literally excavating points by looking at binary and denary systems not as random, isolated facts, but as massive connected structures. Welcome everyone, I'm your host, and today we are focusing entirely on the ultimate Cambridge computer science exam strategy. Listen, whether you are sitting down for syllabus code 0417, 0478, 2210, or even the advanced AS and A-level 9618, this explainer is your absolute survival guide. Now, before we get into the heavy lifting, I want you to picture two students in the exam hall right now. The clock is ticking, the pressure is on. Let's call them Alex and Sam. Look at the mental split-screen scenario we're imagining here. Over on the left, we've got Alex. Now, Alex is brilliant, absolutely brilliant at memorizing raw computer science facts. If you ask Alex what binary is, you are going to get a perfect word-for-word textbook definition. But when the exam paper asks Alex to actually analyze a binary application in the real world, total freeze. Alex overloads the page with raw facts, vomiting data everywhere, but with zero actual analysis. Now look over on the right, we have Sam. Sam absolutely knows the material inside and out, but Sam is rushing. Sam completely misses the command word requirements, literally treating an evaluate question like it's a simple describe question. We can clearly see their flawed answers side by side in our minds, just absolutely covered in red pen marks from the examiner. So why does this happen? It happens because they are treating their knowledge as single, disconnected bone fragments instead of reconstructing the entire living, breathing dinosaur. Well, today, we are going to fix that completely.
Here is our excavation map for today. First, Section 1, the binary fossil record. Then 2, concept compression techniques. 3, the rapid method review. 4, anchoring to the context. 5, the 3-pass revision. And finally, 6, the 4-prompt system. We are going to build your knowledge layer by layer.
All right, Section 1, the binary fossil record. Let's start moving beyond those isolated facts.
When you look at the Cambridge syllabus, you have to realize that the topic of binary and denary number systems sits inside a much larger chain of ideas, primarily data representation. Think about our student Alex from a minute ago. Alex writes down, binary uses base 2, ones and zeros, period, end of sentence. But here is the hard truth. The examiner isn't just looking for you to spot a fossil in the dirt. They desperately want you to explain how the entire creature moved, how it breathed, and how it interacted with its environment. If you just leave short, disconnected labels on the page, the examiner's red pen is going to strike, and it's going to strike hard. So the absolutely crucial point here is that you must use precise terminology and explain processes clearly to fully uncover the marks that are hidden deep inside the question. You have to move from mere recognition, just pointing at something and naming it, to deep understanding, and from that understanding, directly to application. You need to decode the command words. Are they asking you to state, to describe, to explain, or to evaluate? To conquer this, the very top students use a framework called PEAL. That stands for Point, Evidence, Explanation, Link. I want you to imagine a 30-second timer counting down right now. Can you spot which type of answer follows this PEAL framework? Is it the one that just lists isolated facts like a grocery list? Or is it the one that makes a solid point, backs it up with technical evidence, explains the underlying process sequentially, and then links it directly back to the specific question? It's always the latter, for sure. When you use PEAL, you are unequivocally proving to the examiner that you understand exactly how binary solves a specific problem. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It is literally the easiest way to make sure you never miss out on these grade-saving strategies.
Moving right along to Section 2, concept compression techniques. This is where we make your terminology actually meaningful.
To make your terminology truly meaningful, a dense micro-lesson on this topic forces you to ask a few fundamental questions. What exact digital problem does binary solve here? What specific device is involved? What process has taken place? And what is the practical consequence for the user or the system as a whole? When you answer those questions first, before you do anything else, the terminology becomes compressed, highly usable knowledge. And this brilliantly illustrates where those classic, painful mistakes happen. You literally must train yourself to contrast nearby theoretical foundations. Just look at the comparisons we have lined up. Memory versus storage, protocol versus service, compiler versus interpreter. Computer science mistakes frequently arise when learners confuse these nearby concepts because they kind of sound similar or operate in the same digital neighborhood. If a question asks you why binary is used in primary memory versus secondary storage, and you mix up RAM with a hard drive, you completely lose the marks. Even if your binary math calculation is 100% flawless, you get nothing. Dense revision notes must train you to compare, not just explain things in total isolation. Think of it like comparing two incredibly similar fossils to determine entirely different species of dinosaurs. If you can confidently and accurately explain the difference between a compiler and an interpreter, or logic processing versus arithmetic processing, you are effectively bulletproofing your exam answers against those tricky distractor questions Cambridge loves to throw at you.
Let's dive into Section 3, the Rapid Method Review. Here is exactly how we diagnose the demand of the exam.
This is where we see the ultimate transformation happen. We are going to take those brutal red pen marks on Alex and Sam's papers and watch them magically transform into beautiful green check marks. The Rapid Method Review perfectly integrates with the Peel framework we discussed earlier. It is a highly technical methodology designed specifically to stop you from panicking in the exam hall and word-vomiting completely irrelevant facts onto the page. If you want to reconstruct the full, perfect answer, you absolutely must follow these 4 steps to diagnose if the task is testing a process explanation, hardware selection, or logical reasoning. Let's do a live rewrite right now in our heads. I'm putting a visual 60-second timer up in our minds. Step 1. Identify the exact requirement. What is the command word? Let's say, for this example, it's explain. Step 2. Classify the elements. Are we dealing with data, hardware, software, or an algorithmic structure? Let's classify it as data transmission. Step 3. Explain the process sequentially. This means writing step by step, logically, so another learner could literally read your answer and follow the entire process from start to finish. First, the Denary data is converted to binary. Next, the binary pulses are transmitted. Step 4. Connect to context. Does the question want causes, effects, advantages? Connect it back. Look at how Alex's original broken answer transforms from a generic binary is base 2 into a precise, step-by-step explanation of binary data transmission inside a specific network scenario. The mark potential progress bar just shot straight from 20% all the way to 100%. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acedexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acedexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, Anchoring to the Context, because I promise you in Cambridge exams, context is literally everything.
You can have the most beautiful, elegant, step-by-step process explanation in the entire world. But if the examiner asks you about a supermarket barcode scanner and you wrote an entire paragraph about a smartphone screen, you are getting 0 context marks. Generic responses rarely, if ever, gain full marks. Whether the digital fossil you're digging up is a cybersecurity incident or a complex manufacturing robotic system, your answer absolutely must stay entirely inside that specific real-world context to gain those full examiner marks. All right, welcome to the interactive workshop segment of our explainer. We have a couple of really fun challenges here. Challenge 1 is a data scan. I want you to imagine a complex computer science data table on the screen right now. It's showing binary processing speeds across a whole bunch of different digital devices. I'm giving you a 60-second timer. Scan it mentally. What is the core trend hidden in that data? Got it? The trend is that industrial control systems prioritize rigorous error checking over raw processing speed when compared to something like a consumer smartphone. Okay, let's take a quick breath. Let that sink in. Ready? Let's move straight into Challenge 2, Find the Flaw. I'm going to read a flawed sample paragraph to you right now. Listen closely. The robotic system uses binary to process movements. Binary is ones and zeros. Therefore, the robot moves efficiently. Okay, you have 30 seconds. Where exactly did they lose the mark? Time's up. Let's look at the examiner commentary. The examiner says, the student named the concept but completely failed to explain how it works in context. They needed to explain that specific binary signals are used to control the specific stepper motors in that exact robotic arm. Real-world transfer matters immensely. The exact same binary patterns appear in banking networks, secure military communications, and local retail checkout systems, but the application of that binary changes absolutely everything about how you write your answer.
Let's push forward to Section 5, the 3-pass revision. This is all about building layered, indestructible knowledge. Get ready because it's time for Challenge 3 in our workshop, Speed Writing. I want you to visualize a 30-second timer counting down right now. Your task is to write one single perfect peel paragraph explaining exactly why hexadecimal is often used to represent binary data in a school system's MAC addresses. Remember your structure: point, evidence, explanation, link. Go. Okay, pause. If you felt a sudden spike of panic there, if you froze up like Alex, it is simply because you haven't layered your revision properly yet. And that is exactly what the 3-pass revision cycle is designed to fix. This layered style is incredible because your final pass actively mixes similar terms, deliberately changes the scenario on you, and forces you to verbally justify your choices. This perfectly mirrors the applied reasoning you'll face in the actual exam. Pass 1 is straightforward. Secure your key definitions and contrasts. What exactly is binary? What is denary? How do they differ fundamentally? Pass 2 is the rehearsal stage. You practice worked explanations, you physically draw out the diagrams, and you write out code-like structures. You practice the sequential steps until they are muscle memory. But Pass 3 is the magic layer. This is where you focus purely on exam adaptability. You take a past paper question about a basic website and you force yourself to change the scenario to an embedded system in a washing machine. You mix similar terms and force yourself to justify the technical choices. This is absolutely crucial because Cambridge exams love to combine pure theory with applied reasoning. They are constantly trying to see if your knowledge bends or breaks under the weight of a brand new context.
Finally, we reach Section 6, the 4-prompt system. This is your ultimate fail-safe memory structure. Okay, let's recap where we are. We've decoded the command words, we've flawlessly applied the Peel framework, and we've mastered our time management matrix. Now, we need an instant recall mechanism. If you're sitting in that freezing cold exam hall, the clock is ticking, and your mind just completely goes blank, this system will jumpstart your brain like a defibrillator. If you can answer these 4 distinct prompts aloud, your topic is ready for the exam. If not, you need to go back and rebuild from a key contrast or a worked example. Number 1, what is it? That's your basic definition. Number 2, how does it work? That's your step-by-step sequential process. Number 3, where is it used? That's your specific real-world context. And number 4, why is it better or worse than an alternative in that specific situation? That's your high-level evaluation. Let's test this system on binary right now. Prompt 1, it's a base 2-number system. Prompt 2, it works by using electrical high and low voltages, represented physically as 1s and 0s. Prompt 3, it's used in all computer processors, for example, a smartphone CPU. Prompt 4, it's better than Denary for hardware because it perfectly maps to the binary nature of logic gates and transistors, making hardware design significantly simpler and far less prone to voltage errors. Boom, right there. That is a 100% full mark answer generated entirely from these 4 simple prompts. It's like having a cheat code for the exam.
I want to leave you with this absolute mandate directly from our source material. Avoiding vague wording and naming devices without explaining how they actually work is the only way to succeed. Specificity is literally the difference between getting a B and getting an A star. The most common, heartbreaking errors usually come from vague wording, confusing similar terms, missing a tiny step in your process, or failing to anchor your answer in the specific context of the question. Don't be like Sam, rushing past the command words and throwing away marks. And definitely don't be like Alex, dropping generic facts that don't answer the prompt. Be the strategist. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
So the very next time you sit down with a past paper, I want you to ask yourself this exact question before you even pick up your pen to write. What exact digital problem does this technology solve in this specific scenario? Unearth the real context, connect the structures, and reconstruct the complete answer. Thank you for joining me on this explainer. Keep practicing, keep analyzing those past papers, and I will see you in the next one.